Hello. In the following example, we want to determine if the equations that we're given are symmetric with respect to the origin. Letter A says y equals negative 2x cubed. To find out if this is symmetric about the origin, we need to replace both x and y with negative x and negative y. So that gives me negative y is equal to negative 2 times negative x cubed. Notice whenever I cube a negative x, that's going to give me negative x cubed. So negative 2 times negative x cubed is positive 2x cubed. Now, notice that negative y equals 2x cubed is not the same as the original equation. However, if I divide both sides by negative 1, that's going to give me y equals negative 2x cubed. And this is the same as the original equation. Therefore, this does have origin symmetry. Another thing to notice, anytime you're cubing or to the 5th power or to the 7th power or any odd power, a negative x, you're going to get a negative out of it. In other words, this is going to change this sign here. Kind of remember that for the following examples. Now, letter B is y equals negative 2x squared. And again, we want to test this for origin symmetry. And for origin symmetry, I replace the x with negative x and the y with negative y. That gives me negative y equals negative 2 times negative x squared. Unlike over here, whenever you square or to the 4th power or 6th power or any even power this negative x, I get a positive x squared here in this case. In other words, what that means is that this coefficient does not change its sign. In other words, you just get negative 2x squared out of it. The left-hand side will, of course, remain negative y. So that's the difference between having an odd exponent and having an even exponent. The odd exponent changes the sign of the coefficient, and the even exponent does not change the sign of this coefficient. Now notice that this is not the same as the original equation. Therefore, if I divide by negative 1, I get y equals positive 2x squared, and this as well is not the same as the original equation. Therefore, this does not have origin symmetry.